Hey folks, today we're going to talk about Dalton's Law. Dalton's Law is actually pretty easy. You just have to think about it a little bit to make sure you understand what the pieces are. Alright, a container holds three gases, oxygen, carbon dioxide, and helium. The partial pressures are 2, 3, and 4 atmospheres respectively. What's the total pressure? Well, this one's really easy. The fact that they're all in atmospheres is really nice. I didn't make you do any conversions, right? But the concept is this is simply 2 plus 3 plus 4, which is equal to 9 atmospheres. All right? So all you're doing is looking at all of the pieces and adding them together. So that part's really easy. Right? If you have two gases, helium and argon, 30% of it is helium by volume. All right? Well, that means 70% is argon. So helium is 30%. The total is 4 atmospheres. So helium is going to be 4.00 times 30%, which is 0.30. And that means argon is going to be the rest of it, which is 4.00 times 70%, or 0.70. Okay? Simply what that means is this is going to be 1.20, and this one's going to be 2.80, and those are atmospheres, because everything's in atmospheres. So 30% is helium, 70% is argon. By the way, if you add those two together, you still get 4.00 atmospheres, which is your total. Okay, so you could have just subtracted one from the other to figure that out. All right, 60 liters of nitrogen is collected over water at 40 degrees centigrade. It's key that it's collected over water. So the atmospheric pressure is 760 millimeters of mercury. So the total is 760 millimeters of mercury. Okay, so the question is, you've got some which is nitrogen and some which is water. So some of that's going to be nitrogen, and some of that is going to be water. Well, how do we know how much is water? Well, we notice it's 40 degrees Celsius. All right, so what we do is we go to 40 degrees Celsius on our vapor pressure table, which is here, and that says 55.3 millimeters of mercury is the water. All right, so this is 55.3 millimeters of mercury is the water. All right. Well, if my total is 760, and I subtract 55.3, I come up with 704.7 millimeters of mercury. Right? So that's the nitrogen piece. That's the 704.7 millimeters of mercury. Okay, because these two together, if you add them up, we're going to add up to 760.0 millimeters of mercury. So the answer to the question, what's the partial pressure of nitrogen? That is the 704.7 millimeters of mercury. Okay, how about this one? We have 50 liters of oxygen collected over water at 30 degrees Celsius. Looking at 30 degrees Celsius, we have 31.8, excuse me, 31.8 millimeters of mercury, and my total is 725. So 725 millimeters of mercury minus 31.8 gives me 693.2 millimeters of mercury. That's my answer. But no, it's not, because I asked for my answer in kPAs. Well, that's easy enough to do. So I take my 693.2, try that again, 3.2 millimeters of mercury. What do I have to do? Well, I have to convert from millimeters of mercury to kPa. Can't do that, though. I can convert from millimeters of mercury to atmospheres, and then I can convert from atmospheres to kPa. And 1 atmosphere is 760 millimeters of mercury. 1 atmosphere is 101.325 kPAs. So if I multiply that out, divide that out, I get 92.42 kPAs. Okay? All right. So that is number 4. Let's look at number 5. We have helium collected over water. The atmospheric pressure is 19.5 psi. At 20 degrees Celsius, we have, let's look at 20 degrees Celsius. 20 degrees Celsius is way down here. We have 17.5 millimeters of mercury. All right. 17.5 millimeters of mercury. All right. So I can do this all in millimeters of mercury. I can do this all in PSIs. I can do it all in atmospheres. It really doesn't matter. But I notice that I'm given my initial information in PSI, and I want my final information in PSI. So let's convert this to PSI so that we do all of our work in PSI. So let's take our 17.5 millimeters of mercury, and let's convert it from millimeters of mercury to atmospheres, and then from atmospheres to PSI. And 1 atmosphere is 760 millimeters of mercury. 1 atmosphere is 14.70 psi. If I multiply that out, I get 0.338 psi. All right. So now let's see. I'm starting at 19.5 psi, and I'm subtracting 0.338, which is going to end up being 0.3. So I get 19.2 psi is my helium. And the rest of it, the 0.3, is going to be the water. All right, and here's number 6. This is our last one. I have 30 liters of xenon collected over water at 25 degrees Celsius. Well, let's look at what 25 degrees Celsius is. It's all the way down the bottom of the page here, and it's 23.7. So 23.7 millimeters of mercury. And the atmospheric pressure is in kPAs, and I'm trying to get to atmospheres. Brother. All right, well, let's just do it in kPAs. It really doesn't matter. We have to do it in something, right? So, and folks, it really doesn't matter. You can do this in kPAs. You can do it in atmospheres. You can do it in millimeters of mercury. It really doesn't matter. Your final answer is going to have to be in atmospheres. All right. So let's do the math in kPAs. So I have 23.7 millimeters of mercury, and I convert from millimeters of mercury to atmospheres, and I convert from atmospheres into kPAs, which is 101.325. So that's going to give me, if I do that math, I get 3.16 kPAs. So if I now take the 122.4 and I subtract 3.16 or 3.2, because I have to go and match that number, right? So I'm going to have 119.2 kPAs. So that is the pressure of xenon. Well, now I have to convert that, 119.2 kPAs. I'm asked for my answer in atmospheres. So I have to convert from kPAs to atmospheres. That's an easy conversion. That's 1. And that's 101.325. This is slightly more than 1 atmosphere. It ends up being 1.18 atmospheres is my answer for xenon. All right, that's it. If you have questions, guys, see us in class. We'll be happy to answer them. Have a great day. Take care. Bye-bye.